Hey guys, today we are looking at 8.5's notes, which is all about recursive sequences. This is our last section in Chapter 8 for sequences in series, so after this we'll be working on just getting ready for our Chapter 8 test. So, for recursively defined sequences, we have two different ways that we can write a rule for a sequence. Everything we've been doing so far this chapter has been what we call an explicit rule. Explicit just being the direct way of finding a term based on what the position number is. So if you remember back in the beginning of the chapter, we talked about a sub n versus n, where n was the position number, so you know like what place it is in the sequence, in the list. The term is the actual number that's there, so a sub n being the term that is in position n. In an explicit rule, we can just pick out what term number we want to be, plug that number into our equation, and it tells us what that term would be. So if we wanted the 10th term in my sequence, I would plug in 10 for my n value, and whatever number I get back out as my solution from my equation would be the 10th number in my list. That's what we've been working on. A recursive rule is a little bit different than that, because a recursive rule is based on the term that came before it, and then some rule to get me from one to the next. So you might have, you can write a recursive and an explicit rule for the same sequence and both be correct. It's just different formats. So with a recursive rule, again, you have to have the previous term that came before that term that you're looking for, and then you apply that pattern, that equation, that way of changing to get from one to the next. So there's pros and cons to both of them. With an explicit rule, obviously if you're looking for a term, it's easier to work with, especially if you have a term that's far out in the list, far out in the sequence, like the 10th term, the 20th term. But your recursive rules, in general, are easier to write because all you need to know is the starting value, that very first term in my sequence, and then how I'm getting from one to the next in my sequence. I don't need to know a specific a sub 0 value. I don't need to know what my base multiplier is or anything like that. We've had to do with some of the more complicated equations we've dealt with so far, throughout the rest of the chapter. So that's a benefit of recursive sequences. So we have kind of some formulas, and I'll show you what it looks like when we're writing a recursive sequence for both an arithmetic and a geometric sequence. In both of these, we need to have some starting value, so we have to define what a sub 1 is, the very first term in my list, whatever that is. I'm just going to put that there. Obviously, we're going to fill that in with a number, but we say, hey, a sub 1 is this. My list starts with this number. My second part tells me how to get my random term, so a sub n just being the term I'm looking for, and it's always a sub n minus 1, which a sub n minus 1 is just the term that came before the term I'm looking for. And then since we're dealing with something that's arithmetic, remember arithmetic means a constant addition or subtraction, so we're going to be adding d, which in this case is that common difference. Common difference. So it looks a little bit weird, but as soon as we start using it, it'll make more sense. Because like here in this case, if I, for example, wanted to know what the 10th term in my sequence was, if I wanted to know a sub 10, I would take a sub 9, because that's 10 minus 1, a sub 9, and then add whatever my pattern is, add my common difference to it, and that would give me my 10th term in the list. So my geometric, very similar. I still define it as whatever this first number is. A sub 1 is this thing. That's my first value in the sequence, my starting value. But in this case, since we're geometric, remember we're taking my common ratio and multiplying it by the previous term. And minus 1. There we go. So in this case, r is my common ratio. So how I get from one to the next, again, is my multiplication in a geometric sequence. So r is just my multiplier. D is how much I had to add or subtract. So a little bit different, but in general, again, you're still looking for the same things. You're just looking for a starting value. You're looking for some common difference or a common ratio, a multiplier or an addition or subtraction to get from one to the next. So not a whole lot different. It's just our answer looks different format-wise. Okay. So in box 2, they are asking us to write the first 6 terms of the following sequences. and now it's defined recursively. So this one not stacked over top of each other, but still given two things. I'm given, for number 1, that a sub 1 is 2, and that a sub n is a sub n minus 1 plus 3. So what that tells us, this a sub 1 being 2, that's my first number in the sequence. A sub 1 is just the term at the first position. They're telling us we start with a 2. And this plus 3 is just telling me how I get from one to the next in my list. So I'm adding 3 to get from one to the next. So 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. And that is 6. So my list continues, but they just want the first 6 terms of the sequence, so there's the first 6 terms. That's all we have to do. Number 2 is set up geometrically. This is a geometric sequence, and I know that because now my pattern here is multiplying by 3, but I still start with a sub 1. They tell me my list starts at positive 1. And again, 3 times my previous term is how I get from one to the next in my sequence. So 3 times my 1 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And then 81 times 3 is 243. And there's my first 6 terms. Obviously, feel free to use a calculator if it's something that's a little bit uglier or not. You're not super confident in your multiplication skills, especially towards the end of the list. Totally fine. But that would be finding the first terms of a sequence, given it recursively. The other thing that we'll be asked to do is be given a sequence, and we have to write the rule recursively. So again, for our recursive rule, we need 2 things. We need to know what the first term of my sequence is, which that's always super easy. It's directly from your sequence. You just look at that first number. Hey, there's a sub 1. So in the case of number 3, a sub 1 is negative 30, my first term. Now, this next part is different whether it's arithmetic or geometric. So we know this, obviously the box 3 title says it's arithmetic, but we can see going from one to the next in my sequence, I am going up 12. Right, we're adding 12 to get from negative 30 to negative 18. I'm adding 12 to get from negative 18 to negative 6. Adding 12 to get from negative 6 to 6. Adding 12 to get from from 6 to 18. So that is D. That is my common difference. So the way that I'll format this, and this is, you'll have this, it's on your cheat sheet for the chapter. It's on your formula sheet that if you don't already have it, you should have it, the next day or so. That's on the back side of that cheat sheet. I have it set up so that you have arithmetic and geometric equations, both explicit and recursively. So here the only thing that changes is that now I'm going to replace my D with 12. So I'm adding 12. Okay, so that's my rule recursively. If we take a look down below, number 4 is asking us to write the explicit rule for that exact same equation. So remember, when we're trying to do this, our explicit rule for an arithmetic equation, a sub n equals d n plus a sub 0. And remember that a sub 0 term is the number that comes right before my list starts. So not my first term, but the term that would have to come before that to give me the first term. So a little bit weird. It acts like our y-intercept, because obviously this is very similar structure-wise to slope-intercept form. So you can do this a couple different ways. You could just work backwards and say, okay, if negative 30 is my first number in the sequence, if I had to add 12 to something to give me negative 30, that something would have to be negative 42. Or what you also could do is plug in things that you know. You could pick out a particular term, and especially in this case, because we already know my common difference is 12. We could say that the the first term is a sub 30. I can plug in my common difference, which is 12. Negative 30 has a position number of 1 equals a sub 0, sorry, plus a sub 0, and then solve for a sub 0, which 12 times 1 is just 12. So I have to subtract 12 from both sides to get an a sub 0 of negative 42. So our explicit rule would be a sub n equals negative, 12, not negative, 12n minus 42. So that would be the rule that would get you directly to whatever term you're looking for based on which position it's in the sequence. So a little bit different, but again, they describe the same sequence. All right, last box, number 4. Doing the same idea here, but except for with a geometric rule, which you should probably, at this point, you should be able to tell when stuff is growing linearly versus exponentially, which is arithmetic versus geometric. The numbers grow a lot faster, or in this case, shrink a lot faster when it's a geometric, because you're multiplying, or in this case, dividing by something to get from one to the next. So, that is part of it. Obviously, here again, it's titled as geometric in the box label, but it's not going to say, hey, write the recursive rule for this arithmetic sequence when it comes to the test or on the homework tonight. So, in this box, number 5, we're asked to write the recursive rule for the sequence 500, 100, 20, 4, 4/5. So, recursive rule again, I need a sub 1, and then a sub n. So a sub 1, in this case, 500. It's just my first term, super easy. Now my rule to go from one to the next is a little bit tricky because we know in this case it looks like dividing by 5, right? If I divide by 5, 500 goes down to 100. 100 divided by 5 is 20. 20 divided by 5 is 4. 4 divided by 5 is 4/5. But remember, our R value that shows up in our equations for geometric has to be the multiplier. Just like when we were doing exponentials back in chapter 6, we had to have our R value be the multiplier. In this case, if it looks like division, we just put it as a fraction, 1/5. So that's my multiplier, that's my R value, 1/5 times a sub n minus 1. So that'll be my rule recursively. Part B, number 6 is asking me again, write the explicit rule for this sequence. So now, remember, for our explicit rules for geometric, it is very, very similar. It uses all the same stuff. A sub n equals a sub 1 times r to the n minus 1 power. So I already have both of those two pieces of information. It's just rewriting it using a different label. So a sub n equals 500 times 1/5 to the n minus 1 power. And that would be my explicit rule. Alrighty, well, that's all I got for today. Down there at the bottom is your homework, page 447 and 448. You're doing 4 through 22 and then 30 through 48, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.